Problem 3. The sum of 2 to the 2003rd power and 2003 to the second power divided by 7 has a remainder of what? So, first I want to go over that one of the properties we went over. The remainder of sum will always be equal to the sum of each of the remainders. So what I'm saying is instead of actually, calculating 2 to the 23rd power and add that with 2003 to the second power, and then take that sum and divide that by 7 and then find the remainder, instead of doing that, we can find the remainder divided by 7 of each of these numbers separately and then add them. So that's everything that this equation, this rule, this property is saying right here. So for 2003 to the second power, we can, that's not going to be easy, but it's going to be doable, right? So what we really need to think about is 2 to the 2003rd power, because we're not going to multiply 2003 times. So there must be some sort of pattern here. So the first thing I'm going to do is make a table just to see what types of patterns we can get. So we have one over there and one over here. So this top right here, this top row is going to be the dividend. So what's the big number we're dividing? And this bottom right here is the remainder. So first I have 2 to the first power, which is 2. 2 divided by 7 has a remainder of 2. 2 to the second power, which is also 4. 4 divided by 7 has a remainder of 4. What about 2 to the third power? That would be 4 times 2, which is 8. 8 divided by 7, well, 8 is now greater than 7, meaning that it will have a remainder of 1. Let's do a few more. 2 to the fourth power would be 16. 16 divided by 7 has a remainder of 2. One more. 2 to the fifth power, 32. 32 divided by 7, well, 4 times 7 is 28, so it will have a remainder of 4. 2 to the sixth power, which is 64, will have a remainder of 1. As you can see, this is a pattern right here. It's 2, 4, 1, 2, 4, 1. So using this pattern, we take 2003 because that's the power that this number is by, and we divide by the number of terms in each round that this pattern goes by, which is 1, 2, 3. So divide this by 3. So we're going to divide, and we are going to get remainder 2. So this remainder 2 actually isn't our final one. It doesn't mean that the remainder of this would be 2. So now we're looking at the second term that's in this pattern. So 1, 2, and don't get confused by this. There's a lot of remainders here. So the actual one is 4. This is going to be the remainder. For 2003 to the second power, we can actually just multiply that. It's not going to be that hard. So we're going to do 2003 times 2003. So for this first one right here, we're going to get 6,009. And for the thousands, we add this, and we are going to get this is a 6. Now we add. So 900 12 104. Now we're going to divide this by 7. So 401. I'm going to make this smaller. Make this smaller, and so we have more space. and we're going to have 4012009 divided by 7. So this, we're going to have 535 minus this 5, 1, 7, 49, 2, 2, 3, 21, 1, 0, 1. Okay, we're going to have a remainder of 3, 0, 4, 28, 2, 9. We are going to have 4, and we're going to have a remainder of 1. So after all of that, we're just trying to look for this one little remainder, and that's 1. And remember, we're going to find the sum of the remainder. So 4 plus 1 is equal to 5. So basically, our final answer is 5.